And my first is 2x, and my second is the inverse hyperbolic sine of u. So I'm going to do, for my derivative, it'll be the first, which is 2x. The derivative of the inverse hyperbolic sine is right here. Is u prime. So what's u prime? 2 over the square root of u squared plus 1. So the square root of, what's 2x quantity squared? 4x squared plus 1. So now how can I write this a little prettier? 4x on the top and nothing cancels. Don't even try to cancel. All right, so let's take a look at another one. Oh, the second half of the product rule. Well, goodness gracious, what am I thinking? So plus the second times the derivative of the first, which is 2. So then I would just take this plus 2 times the inverse hyperbolic sine of 2x. And I'm done. Now I'm done. Yay. Yes, for real, I'm done. Okay, so we'll look at one more of these. Y equals the inverse hyperbolic cosine of the secant of x. Okay, so what rule are we going to use here? Chain. Actually, we can just use the inverse hyperbolic cosine rule.
She fooled all y'all.
We can just, if it is the chain rule, what you need to realize is that these rules, the inverse hyperbolic cosine of u, it does the chain rule for you. So we can say, well, it's u prime, so what's the derivative of secant x? Okay, so the top will be secant x tangent x. And then the bottom, what will the bottom look like? Square root of u squared, which is secant squared x minus 1. Now, do you suppose there's any identities we could use?
Probably about 8 of them.
Probably about 8 of them. Now, does this rule, is this identity, the secant squared x minus 1, is that on here?
No. Maybe.
Does this have anything with regular trig functions here? No, these are not regular trig functions. These are hyperbolic functions. So the regular trig functions, you might have to look at your identity sheet. Secant squared x minus 1, who knows what that's equal to? That is equal to tangent squared x. And what's the square root of tangent squared x? Tangent x. So I actually then have secant x tangent x over tangent x, which is secant x. So my derivative is secant x. Yep. Well, the only reason you did that was because you had a regular trig function in there. Okay, so let's look at a couple of integrals.
Yippee!
So the integral of dx over x radical 4 minus 9x squared. I sure can. Okay. Now we have lots of integral rules. And I guess it doesn't hurt to first look at the integrals and see if this matches any of, basically your rules, integral rules that have the radicals on the bottom would be the inverse trig and the inverse hyperbolic. So first I'm going to look at these inverse trig ones down at the bottom, 16, 17, and 18, and I'm going to say, do any of these three resemble this? Okay, the arcsecant does, but why can I rule it out?
Because you do not have...
Look under the radical, please. It says u squared minus a squared. Now, what is u? U has the x, and a is a number. So this would have to be the x part minus the number part. Is that what we have here? No, we don't. We have the number part minus the x part. So actually, none of these appear to work. Quit. No, we turn it over to the other side where we have the inverse hyperbolic integrals.
Ooh.
Now, I did forget to give you some rules on here. Did I? Maybe I didn't. No, I guess I didn't. Okay, so these are fine. So these are our other integrals that we have. So does this match any of those? Doesn't it look like the third one it might match?
Yeah.
Okay, so, because that's got the a squared plus or minus the u squared, and I happen to have the minus one. So in this problem, what is the a? 2, and what is the u? 3x. So do I have to use substitution? Well, what would the du be? 3 dx. So I have to use substitution because the du is something other than 1. If du equals dx, you don't have to use substitution, but that's not the case here. So I have to go and substitute. So what am I going to put under the radical? What's that 4 going to become? A squared. Well, it can stay 4. That's fine. But what's this part going to become?
U squared.
U squared. Okay, what am I going to replace the dx with?
3.
1/3 du. And what am I going to change that x into? What does x equal? X is 1/3 u. Okay, so that x, how did we get that? How do you get that x?
U equals 3x and you divide by 3.
Good. So x equals 1/3 u. So I'm going to replace this x with 1/3 u.
I'm the smartest man.
Now, pay attention. I've got a 1/3 on the bottom and a 1/3 out in front, which is on top. What happens to those 1/3s? They cancel. So now I have the integral of du over u times the square root of 4 minus u squared. Does this now match exactly that integral? Du over this one, u square root of a squared, which is 2 squared, minus u squared. Does it match exactly? So now my answer is going to look just like it says. My answer is now going to look exactly like it says right here. So what was my a here?
2.
And what was my u? 3x from up above. So I'm just going to, wherever I see an a in this formula, I'm going to put a 2. So I have negative 1/2 natural log of 2 plus the square root of 4 minus 9x squared, because 3x squared is 9x squared. That whole thing over the absolute value of u, absolute value of 3x plus c. And all I had to do was, once I got my integral in this format, identify the a and the u and plug them in place of that answer. But I had to, why did I have to use substitution? Why couldn't I have just plugged this stuff in?
Because it was 3.
Because the du is more than just dx. It was 3 dx. Okay.
Oh, where the day?
Well, you may have to complete the square here. I mean, that, you know how to do that, right?
Yeah.
Okay. So, yeah, I'm just going to let you work on your assignment now. Where is the assignment sheet? Who has an assignment sheet for me to look at? I bet I have one. Oh, yeah, I found it. Okay, so the assignment, let's see, what do I want you to do? Do I want you to do the whole thing?
Probably not. Language,
I'll get rid of and do 73 through 81 by 3.
Do the rest of them?
Yep.
Alright, bye, Mrs. Karen.
See ya.
No. 3A. 3A what? 4A. Wow. You're supposed to be looking. No, yeah. Finally. I know, seeing that on the bottom is just like,
That's why I asked. I'm not gonna have
this close obviously goes by like. No. It does. I don't know. Like, I actually enjoy it.
So too.
It's review learning and stuff.
Number 32 is a test time.
Yeah, but.
So I'm saying we can review this next class.
I have so lost, so. Next class we'll have review. Let's go.
I think it would. What are we doing?
Third, yeah.
I really hope this group.
Right for me.
Yeah. Dude, Saturday is gonna be brutal.
Dude, I have to get up at 4:07.
What number is this?
31. Alright, I'm retiring.
You are Joel. You're a Joel.
I cut off on
You are Joel. I am not Joel.
everything. So wait,
Yeah.
I can't wait. I like, even if I don't get it, I can't wait. Ask your grandma to see what it's about. Like, I cut off on all, like, videos, stuff that they released for us. But anyway. They showed a poster of, basically, on one side, like
What did I say today?
in the middle.
Nothing. Absolutely
Like
nothing.
destroyed city of.
It's 73 to
And on the other side was block.
Oh.
Not by at the same time. It's just not by three.
Okay. Yeah, like all the money was from like when they were going.
Is it 73, 76?
Yeah, she said you have a bunch of
I'll go yours.
Mine's 29.
I won't be going to that one.
What?
I won't be going to that one.
Why?
Let me just look it up. I don't even know. I'll be there. Oh wait, I'm not right.
I don't know.
Everyone
Just my family's invited, not me.
We just did mail it to you. Not here. This is the one we're doing. Yeah, sign in your.
She said you have a bunch of different.
No, she's
Yeah.
Is this, no, this has 3A.
Okay.
Ah, the page is 396, people. 396, not 399.
Really? Yesterday I went in, I said the wellness, I was going to eat spittle, I just went home. It's just like,
Page 396.
Huh?
Carrie, you guys look. Wrong page.
Yeah, I was like, wow, I know how to do this. Just erase all of that. I was like, I can see it.
No, I think I'll.
I'm not getting that at all.
Yeah.
Because I got like a.
Oh.
It's in the one type. Yeah.
Freshman year Spanish.
Well, so what?
Yeah, and then you just left us.
Really?
Who are you?
Yeah, you transferred out.
Yeah, you left our
They
class.
take you. I was in Brazani.
Yeah, then you left.
No, yeah, I left halfway through because I got a bus, and that's why now I'm getting